variables, and it's like, okay, here's a little loop that just copies everything into the right place.
Yeah, it's pretty incredible. I'm gonna actually see if I have my.
Rust as well too. I tried to ask simple like find all string satisfying regular expression, and it just split out correct code. And I haven't found the same code on Google, so I don't know where it got the code. It's pretty interesting, but it can write quite big functions and programs in Rust.
It really does a great job. So folks that are I just started streaming too. So I just want folks to know that you're in the right place. This is the monthly meetup for the Boston Healthcare Technology Group. And we will probably start our presentation in about 15 minutes, but I just wanted to start the stream early as we're talking about some cool stuff here. And so we were just, one of the things I want to share with you folks is, since we were talking about ChatGPT, and I literally have been data wrangling all day with it, I'll show you like some of the cool stuff, like how I've some tips how I've been using it. So you can see literally this thread. I won't bore you, but I mean, all day long I've been working in this thing and just help with various T-SQL statements. But one of the biggest tips that I've learned recently that works really well, that ChatGPT does well, is I don't only ask for the update, right? So you can see here, I'm like, okay, give me an update query that will do whatever it's going to do, right? But then what I'll do is ask it to also provide a select statement so I can test it first. That's super cool and cuts out some time, So this is a new technique that I've just picked up. So what I'll do is I'll say, okay, give me the thing, give me the test, and then of course I'll obviously do the test first, the query analyze it, make sure things look good, and then you can you can go to the update again obviously you need to, it's not a replacement for experience. You need to know what the thing is putting together. But I find now, like, if you do have the experience, it's almost more like building with Legos, instead of building with precise commas and semicolons and words, if you will. It's fascinating.
I mean, you need some level of experience, but I feel like if you have a little bit of experience, it lets you do a lot more than you could.
Oh, a ton. Don't get me wrong. No, there's huge benefits for everybody. Don't misunderstand what I'm saying. But what I'm getting at is, I necessarily like, if I'm a data analyst, I'd be careful about just adopting ChatGPT and calling myself a data scientist, right? Like there's a little bit of a jump there that you need to be careful of. And so that's all I'm getting at, And so, but that said, I think if you take a data scientist that has, great subject matter expertise, and then you pair them with the tool, that from my experience, that's where people are seeing the most, the best value. I don't use it quite as much, and I don't use the GitHub one that's embedded into VS Code. Yeah, the Copilot one. But that's just because I don't spend a ton of time lately in VS Code. I spend a little bit, but I've been doing a lot more like data wrangling and Rust and T-SQL. So, I'm in there a little bit, but my T-SQL, I know there are extensions for VS Code, but I still like SQL Server Management Studio, Even when I have even Azure Data Studio, like, it's very slick. I like it and everything, but I find myself going to SQL Server Management Studio for a lot of this stuff.
One of the challenges with ChatGPT sometimes invents new API. Like, if you try some unknown library, like there is library to download from GitHub, it asks you how do you search repository with certain language. It can invent some function like search by language.
Yeah.
That function doesn't exist at all. So sometimes the ChatGPT gives you code that doesn't run at all, but that's not the biggest issue as long as it's not wrong.
Yeah.
Are you using the paid GPT 4 or are you using the free one?
I think for that it was free one.
Okay. Because I'm paying the monthly fee to get the newest version, and it's so much better than the free version.
Yeah, I that's the guidance I give the people right off the bat, is to pay for it. As a matter of fact, not only do I pay for it for myself, but I've started paying for it for everybody on our team and anybody that I like. I've even started asking contractors, like, do you have the paid version of ChatGPT?
And if you are someone, if you are someone that doesn't want to pay and you're not using anything that you don't want other people seeing, like, there's other AI services that use version 4 that that you can use for free and sort of just
Yeah.
get the full version that way. But
Yeah.
then you've got a whole other set of eyes looking at whatever you're putting in. So.
Yeah, no, I love that idea of experimenting with, different networks. Even some of the ones we're very interested in, some of the large language models that can run on-prem as well, or in private cloud. And, maybe we'll get a chance to talk about that a little bit today as well. And with that said, I may actually just start to roll into our presentation. It's or not the presentation, but just sort of officially start the meeting, if you will. I'll leave ChatGPT open just in case we want to play a little bit more. And so I should start by just talking a little bit about the Boston healthcare cloud community, and also big news, the Chicago healthcare cloud community. So we've launched a new group in Chicago. We already have a few hundred members, and that's actually the reason why we're streaming tonight. We've stopped streaming our monthly meetings, and we do in person only. We invite people to the meetings, but because we've bought on this new Chicago group, and we don't have anybody in Chicago to manage the group for us yet. Hint, hint, if you're watching this and if you're in Chicago and interested in organizing a group, let me know. And if you are listening from Chicago, welcome. And again, this is a monthly meeting in the Boston Healthcare Technology User Group. You can do a quick search for Boss Hug and Linktree, or just search for our group, and you'll find everything that you need in the Linktree. So we've been building the group for going on 2 years now. So we're getting fairly sophisticated in terms of systems. You can see we've got our meetups, links here, Eventbrite, etc. And also a call for speakers. So if you're interested in speaking, please let us know as well. And then something else I'm really excited about actually is we've also started the Twitter community for it doesn't look like I'm logged in on this computer. If you go to Twitter and you search for Microsoft Healthcare and HLS under communities, we've actually launched a new community, and we're getting support from some of the folks at Microsoft, as well as Microsoft MVPs and Microsoft RDs. And so I'm excited about this idea of growing a community on Twitter. We do this today using Discord, so we do have a Discord community. I view Twitter as complementing this, if you will. And so these might sound like trivial things, but in the spirit of our mission, which is to try to get as many folks involved in healthcare tech, especially new people into the industry, we found that community is important, and that's part of why we're building out on Discord. Is we like the idea of being able to attract the however many users Discord has now, into the industry and into our community. So tons of information. Just check it out when you have time. Email us anytime. hi@realactivity, and there's contact form on the Linktree as well. And so with that, I think I'd like to get started with today's talk. And so we'll be a little bit flexible. We're going to talk about Rust and the different parts of Rust and why we might use it and how we might use it. And then also talk about how it relates to some of this newer stuff that everybody's excited about. So these large language models and foundational models and sort of semi-private LLMs like the Azure version of OpenAI. So we'll touch on that a little bit too. Hey Matt, how are you? So let's just start at the very beginning. One thing that you might know is you can do a quick search for GitHub and my name, P. Swider, and then you'll find this Rust Code Camp. repo. And so this is something that I put together for this presentation, and not only for the meeting today, but I gave this presentation at a code camp, and I'm actually publishing some articles as well. And so this will be a companion to the articles. For the Matt and there's snacks and sushi. I'm sorry, I didn't. How do you pronounce your name? Priyaranjan.
Sorry, I registered from Meetup.
Oh, okay, perfect. Yeah. Help yourself to sushi or snacks if you want, and there's some drinks up there as well. Everything's super fresh. Just got here about 15 minutes ago, and should be still nice and cold.
Do we need a laptop for this?
No. There'll be just presentation for now. So to get started, what I've done is, instead of putting together PowerPoint slides for the presentation, I like to use this GitHub repo. I find it nice for multiple reasons. One, it just gives everybody access to the same stuff I'm looking at, and it just seems like a great way to share, especially when you're talking about code. And there's a link here as well. I'm not going to bore you with this now. It's just a link to my LinkedIn introduction, but I should just give a quick introduction since I'm going to be talking about programming. My name is Paul Swider. I'm the organizer of the Boston Healthcare Cloud community, and also the founder of Real Activity. But my real passion is programming, is code. I've been a developer. I started programming before I was a teenager, which is probably not a big deal today, but many years ago, that was a big deal. There were not computers everywhere. We were one of the very first elementary schools to get an Apple IIe, and I was able to get started. But so, long story short, I spent the first 10 years of my career helping people to get onto the .NET platform. The second 10 years in enterprise collaboration, and then the third almost decade now on enterprise cloud, blockchain, some of this new AI stuff, and also industry cloud, and especially Microsoft Cloud for Healthcare. So I work closely with the Microsoft Cloud for Healthcare team in Redmond when it comes to creating content for training for partners and whatnot. And so I would consider myself an expert in that space as well. And so with that said, let's just do a quick introduction. Let's just acknowledge that Rust has been here for a while. Can you guys see the font? Okay, maybe I should make it a little bigger. So a little bit about the history. It was created in 2006 through 2009 is when the first hints of Rust started coming together. Mozilla started to sponsor it in 2009. I think it's safe to say that the Rust as we know it today evolved mostly from 2012 to 2015. And so its goals are safety, speed, and concurrency. And so I think one of the things that's really important to acknowledge before we jump into this is, who should learn Rust, right? And I want to be careful about that, because I think it's okay to learn a programming language just for fun, just for a hobby. So let's just acknowledge that, there are some people that might actually want to learn the language just for fun. But aside from that, there are some very specific use cases where I think the language should be, strongly considered. And so the basic rule of thumb now that I find is that if you're starting a project that does not or will not use a language that has garbage collection, then there's a very good chance that Rust may be a fit for what you're doing. So, if you were to ask this question 12 months ago, it might not be as clear cut. And people would say, well, that's sort of silly. You know, C is everywhere. And I've been programming C for decades. Like, why wouldn't I just start new projects in C? And there's actually a compelling reason not to do so. So apparently, according to the Chief Technology Officer of Azure, Mark Rusinovic, we can eliminate, boy, I hate to use this number now because it's vague and I don't remember the exact number, but it's literally around 60-70% of code issues from a security perspective. And that's because most of the security vulnerabilities happen at the memory level, and how C, it's really not how C, it's how the programmers that use it, because they're responsible for writing and reading memory. And so this you know, has caused a problem later in life. So I started later in the life of C, right? So this totally took me by surprise. You know, I saw a random tweet from the CTO just over a year ago where he started talking about this. And then about 6 months ago, really started using much stronger language and literally coming out and saying all new projects, non-garbage collection, right, should be started in Rust. And C should be considered a legacy language at this point. That's the CTO of Azure for Microsoft. And as you know, Windows is built on C. Everything that Microsoft has built throughout the years is built on C. And interestingly enough, I heard at Build this year, there was a big announcement where they had rewrote the some of the core libraries to Windows. So now I haven't had time to research this and dig into it, but of course one would ask, you know, when they were faced with this task, did they rewrite the core libraries in Rust? I'm assuming, you know, but maybe not, right? There are other languages that we can pick. So I'll pause for questions first there. I think that's sort of a good intro. Yeah.
Why did you specifically mention garbage collection as something that was a factor?
Well, if you're using, so languages that have garbage collection, they actually have a process that runs and it watches the memory for you and it protects it and it makes it much easier for the developer to not make a mistake. And so those languages can be more secure from a memory perspective. The problem with that, though, is that it adds overhead to your program because you've got this thing that's always running on the side that's checking your memory and making sure that what you're doing is safe, etc. And so that's why we call out garbage collection. So and so the other key thing is if you're able to use a language that has garbage collection, then you don't have to worry about the memory security issues. So if you decide, okay, I have a use case, for example, I want to write an exe to run on this watch that can execute as fast as possible to just output data to, I wouldn't necessarily, you know, it gets a little tricky, right? Because the minute you start calling REST, then you slow yourself down. So I'm not saying I would send it to a REST service necessarily. But if I did want to write something super, super fast that could run on this watch and then pipe out data, then I would most likely pick a non-GC, we would say a non-GC, a non-garbage collecting language for performance reasons. And so the program could actually fit on my watch is the other thing. Some of these garbage collection, like for example, there's C#.net is one of the most common ones that we hear about, right? And so that there's a huge footprint there. So I'm not even sure if you would be able to get that to run on a watch. I'm sure an engineer somewhere in the world can, but you know, generally speaking. So does that help a little bit? It's a great question.
Yeah.
Okay, good. And it actually tees up the next point as well, which is, and that's what I was getting at with this, you know, this watch example is that, you know, if you're looking for use cases where you might not use garbage collection, it's going to be where you want safety, speed, and concurrency. And that's again the top three goals of Rust. So concurrency is interesting as well. So I talked about safety from, what just happened? Uh-oh.
I have some questions.
Yeah, go ahead.
So did it take so long for people to find out that Rust is so good at garbage collection and security?
Rust does not do garbage collection. Rust is it is not a garbage collection language, but because of the way that it does its compile checks at runtime, that's what makes it more safe than other non-garbage collecting languages like C. Does that make sense?
Yeah, that makes sense.
Yeah.
So a lot of things are made in C and they are still being developed, such as Linux kernels are still being developed on C.
Yeah.
So why are people not moving to Rust?
They will. I guarantee they will over the next years. Every time a cloud gets hacked, every time there's another SolarWinds, where a nation state basically can sit on the Azure cloud or AWS and copy data for a summer, out of people. As long as that keeps happening, eventually people are going to get the message and they're going to start moving stuff over. I think there's probably a reason why people aren't going around sounding the alarm either, because the minute you start sounding the alarm, you're also sort of letting folks know about the issues, right? And also where I bet it gets a lot more dangerous is with AI now, because now you can point AI at the code and say, show me where there's going to be a memory leak that I can take advantage of, right?
There are a lot of tools also which will show where there will be memory leak.
Mm-hmm. Oh yeah. Are you asking? Sorry.
No, I'm telling.
Yeah. No, it's a very, very big issue. So again, the three goals of Rust are safety from a memory perspective, and it does this because it does the compile time checks for memory. It's fundamentally different in how it deals with writing and reading from memory, and it does as much of that as possible. I'm sorry, during compile time, not runtime. And sorry, just real quick. And then the second thing is speed. And so I had just talked about that. And one of the things that helps with speed is also concurrency. So one of the other issues that you'll run into in using C, and not just C, but some garbage collection languages as well, like, let's just say C#, is this idea of handling concurrency in multiple threads, right? So this has always been something that's been difficult to keep track of. And so, we have libraries to help us do this, right? To try to figure out when, what we said, how long we should wait. And it's all really, it's about solving the same problem we've been working on for 30 years, which is inter-component communication. Like it started with Ole, between Excel and Word. But really what that was, it was like, okay, wow, we can finally take information from one computer's memory and then paste it into another computer's memory, right? And boom, these problems were born from that day forward. Just like any technology, it'll introduce some good things and bad things. So what's cool is, what I'd like to explain is how Rust does this. So one of the things I really like about the language and I find fun is that is how it deals with concurrency. And so it uses this model of, I call it fearless concurrency, but I think they may have another name for it, but that's close enough. But basically what this fearless concurrency will do is it will, at compile time, it will figure out which thread should execute when. And then, so what that means is at runtime, it doesn't have to do that. You don't have to wait. You don't have to do your, if you ever look at Task Manager and you see all those threads, it's like, you don't have to deal with any of that, like Rust just did. And so that helps with performance, because what happens is the horses are ready at the gate. They're ready to run. Like the minute you say go, they just go. They don't stop to check, hey, am I going to have a problem with this thread? Do I need to check for, for locking issues, etc. So this notion of concurrency helps with the speed part. So now, if we were to,
So I have one question.
Yeah, go.
So why didn't people build tools around C and C++ to detect garbage collection instead of reinventing the wheel? So they have invented new language.
Yeah.
And then everybody will have to rewrite everything in this new language.
I think that's probably what they've been doing for the last 20 years, is band-aiding things and patching things and providing workarounds. And, the reality is that it's whatever we're doing is just not working. Because if you just, all you have to do is just pay attention just a little bit, and you'll hear about a constant stream of data leakage and hacks out of the United States. Constant, right? Like, there was just the most recent one was, I don't even follow the stuff from the site, the CISO stuff. I probably follow it more than most, but just last month there was malware that, they say it's probably China, but who knows nowadays? They put it on servers in Guam. And the next thing they knew, it's it's taking over apps in Azure and AWS. You know what I mean? That's just the most recent one. And then you go back to the summer where was it the previous summer where you had SolarWinds, right? And then you had stuff all in between. So to me, it just feels like it's not when or if. I feel like we're on this constant cycle of people just stealing our data. Honestly, that's just my honest opinion. Like, public cloud is just not secure, right? Don't get me wrong, it's secure, like to save some documents and stuff like that. But let me ask you this: if you had a Bitcoin account and that Bitcoin account had $100 million in it, and you had to choose someplace to store that private key, would you store that private key in Azure or AWS?
Doesn't matter.
You wouldn't, right? I can tell you where I keep my keys. Well, maybe I shouldn't, but I will tell you this: like, I use a capsule, and they're burned onto stainless steel, and they won't melt up to 40,000 degrees, and they can be put in a safe deposit box, and a bank can burn down, and I will still have my private keys to get it back, and I will have one on another continent too. Right? So I'll have a backup in a safety deposit box on a completely separate continent than North America. That's how you secure a private key. That's security. I would submit, if you take that private key and you put it up into Azure public cloud or AWS public cloud or Google public cloud, good luck with that. Hopefully it's still there, when you come back, especially with AI nowadays. I think and this is some of the stuff why people are scrambling behind the scenes. They're talking about security and the dangers of AI, right? The danger is the ability to look for keys. I have now OpenAI, interestingly enough. I made the rookie mistake of checking in some code that had my OpenAI API key in it. I literally got an email like within seconds, maybe a minute, from GitHub and OpenAI saying, hey, you just, checked in your API key. We're disabling it. No problem. We got your back. Come get a new one when you're ready. It was that type of thing, courtesy. But my point is, that was AI. That they were doing a find on keys, right? They can respond quickly. So I think the same problem exists. I know it exists when we're looking at languages that don't have garbage collection and memory management. We can use AI to find flaws in these systems, and that would make it worse, right? But the good news is that most of the world has been testing Rust, and people are excited. And it looks like, because of this fundamentally different approach, it is more secure and it is more performant. And so now the key thing is, now that we understand the why and a little bit of the history of Rust and the goals of Rust, I think we should take a minute and talk about, what would be the use cases, right? If I look at this diagram, there's a lot of places here where I would never use Rust, where I could easily get away with something like C#, right? So, for example, if I'm customizing anything in Dataverse or Dynamics or Microsoft 365, on the front end, that's going to be JavaScript all day long, right? And on the back end, it's going to be C# or some Java stuff, right? You have your full stack Java devs that may do something on the back end with the, but clearly you'll see a lot of C# and mixed throughout Dynamics as you're customizing it, et cetera, and extending it. So then, if we start to look at things like IoT Hub, IoT Central, text analytics for health. I would also argue or submit potentially as a service that calls into Azure Health Data Services. Okay. So what do I mean by that? Well, let's pause on this for a minute. And let's imagine a scenario where we're using Microsoft Cloud for Healthcare, the data side. We're not going to dive all into Cloud for Healthcare, but let's just talk about Azure Health Data Services for right now. So real quick, Azure Health Data Services, it basically is how you take your data from the hospital, whether it's Fire, DICOM, IoT, et cetera, and you get it into Azure in a safe way that Microsoft takes responsibility for. So one of the things I think one place where it would be a good use case for Rust is you could use it for data engineering to send bundles of patient data between hospitals and institutions. So for example, take this scenario where you've got somebody like a Pfizer, and they need to work with all the local hospitals because they're going to do clinical trials. They need to get the patient data from all the hospitals, and this is how they do it. As a matter of fact, this is exactly how they do it in a lot of the cases. These are some of Microsoft's first biggest customers with Azure Health Data Services. And so the way this works is Fire is a REST-enabled API that sits on top of patient data, if you will. And so it allows you to extend it to partners and to the cloud. Now, you still have this need to have the various hospitals send or dump their patient data. So typically they'll do this as a zip file. And inside the zip file, there'll be these things called Fire bundles. And a Fire bundle is it's a package of records is the best way to think about it. And inside your bundle, you're going to have your actual data, patient data, medical record, that type of stuff. So what I would submit is a really great use case for Rust is to handle the data engineering between all that. Like if you need something just bulletproof, that's always going to run, it's going to be super fast, and it's going to be secure, I can use Rust, create a service that will go out, get the zip files, make the call into Rust or into Fire, etc., and life goes on. I would also submit that as we start to do more with Fire, which is again our patient data and health data, it's more than just patient data. There's some other data in Fire as well, but it's all has to do with managing patients and the clinical data in the hospital. But if you look in the upper left-hand corner of the box, social determinants of health, what this is actually illustrating is that they're pulling in from another external set of data and adding this, or using Azure Data Factory, and they're adding it to in this case, it's a Synapse Analytics or a Data Mart. And the reason why they're doing that is because that's how you can start to do machine learning and include demographics about your patients, right? So you could say, okay, what was the success rate of this type of surgery where, the zip code was this, and, demographics were, Asian of a certain age, et cetera. You can get very specific using demographic data. And so as we start to build systems where we want to take this social determinants of health data and combine it in some cases with our health data, and then make calls off to these machine learning models or large language models, I would submit that's a good use case for Rust as well. And as a matter of fact, that's one of the reasons I decided to pick Rust up, was because I decided that I wanted to build our API using Rust. So our API, our newest API at Real Activity, is focused on consuming data from Fire, social determinants of health, and PeopleSoft, all sorts of things, places. But now what we're adding is capabilities, the capabilities that are required for our first plugin. So we want an OpenAI plugin for for our app so that providers can query provider data right from, ChatGPT or Copilot, whatever it is that they're using. And so what's fascinating is if you start to look at the architecture of OpenAI plugins, it's really an API with like a registration file. That's all it is. And by the way, what's really cool, because the model is that simple, in theory, you should be able to create a plugin and register it with OpenAI. And you can take that same plugin and register it with like Microsoft Copilot or one of these other folks following this standard, and that plugin should work. That's what we've been promised. We'll see how that materializes, but this is it's a standard. And so again, to create a plugin, so we have something called the Provider Experience Platform, and so we track a lot of data about providers. Providers are your doctors, nurses, nurse practitioners, etc. And so one of the things we want to do is give providers the ability to use natural language to figure out important stuff about their relationship with the hospital and the patients that they're working on and who they're seeing. So in order for us to build this plugin for OpenAI, the first thing we have to do is we have to create an API. And then essentially what we do is we create a registration file that you actually send it to OpenAI, and they will use that thing to register your API. And then what will happen is, whatever, Diane, I'll have to check in with Diane in a minute. Maybe our mic or something isn't working or something, but that's okay. And so I need to start building that API for my plugin. And so we've decided to do that with Rust. And so I hope that gives you enough hook now that we can step back, and now we'll go back to Rust and start to look at some basics again. Okay, but now I hope I've at least answered the why Rust, like why should we take this seriously, etc. So hopefully you at least have that part down. And now what we'll do is let's just back up and look at some fun stuff first, okay? So first of all, remember I said that one of the cool things that I like about Rust is I can write an executable that will literally run on my watch, right? So what you can see here is like really just the most basic Rust program you can write, right? It's the famous hello world. And so the first thing to note is that we have the syntax for our function declaration. And then we have just a real simple, all this is going to do is print out to the screen, hello world Boston. So a couple things to note. I'm using Visual Studio Code. There is an extension for Rust. I've got a few different projects open here for demos. Right now we're looking at hello world. And in the hello world, you can see there's a source folder. And in source, this is where we can find the main.rs, the main file. And this is where the main function is stored. And it really can be that simple. Like I'm not, importing libraries here or doing anything fancy at all. And then what's interesting is, then what you'll need to do is use a terminal. You can use a terminal inside of VS Code. I like breaking out to Windows Terminal. And so that's what we're going to do here. And so you can see I'm actually in that project's repo. And, I can switch to hello world. And then you can see here that I can actually see the compiled exe because it's already been compiled. The last time it was compiled, it looks like 450 on the 8th. And we can do we can compile using Rust C for compile, Rust C. So we'll pass it the path to the code file that you saw. This is a hello world code file, and we'll go ahead and compile that. Now, what's super cool is, I mean, I'm sure we all have different definitions of what cool is, but what I think is cool is that this thing compiles. If you look at the size of this thing, you know, it's minuscule. And by the way, there are switches that you can use in the compiler. I'm confident I can get this thing smaller than it is here. Very, very confident. But even just for out of the box, no setting switches or anything, you know, to get an executable, you know, this small is impressive. So that's compiling. But now you can also, there's a shortcut. So you can do, there's a cargo is like, it is a Rust version of npm, or in the Microsoft world, it is, it used to be NuGet, but they use something newer now, and shame on me for not knowing it off the top of my head, but whatever that is when you're in Visual Studio, when you're referencing libraries, etc. And so Cargo is responsible for registering libraries, pulling them down, making sure that you have the right version, etc. But you can also use Cargo just to run your app without compiling it. That's why I'm showing this to you. So I don't need to do a Rust C compile. I can just do a Cargo run, and what it will do is it will it'll just go ahead and run the app. And so you can see, again, it's just hello world, right? So we're just dumping hello world out to the screen. And then finally, of course, you know, we can run the exe or not. There we go. Hello world.
Question.
Yes, please.
It might be a basic. I'm sorry, I missed the
No.
question. So you mentioned that this can run in variables, and then you're showing the size. So is there a target user you're after, or this is a generic API framework?
Well, so it's one of the things that you can do with it is create an API, and that I'll talk about in just a little bit. But in this example, I'm keeping it really simple and just creating a, you know, simple exe that can run anywhere. We could run this on pretty almost any device that would support an exe. Oddly enough, there is a dependency on a C library. Just interesting. Yeah, and so fortunately, you read into the details about that, but it's worth noting that there is a dependency. And you are right, we did cover a little bit of we covered this just before you got in, but I can say it very quickly that essentially what I asserted at the beginning of the presentation is that if you're starting a new project that will not use a garbage collection language, so for example, C#, right, some of these .NET Core, right, like any of these languages where you're doing garbage collection in the background, I don't know. Please don't. I'm not saying it is for people that are listening online, but that might be another one. So if we're not using a garbage collection language, then that basically leaves Rust, C, and a handful of others. I shouldn't say a handful. There's hundreds of programming languages. You could do another one of my favorites is Haskell, right? Haskell is actually Rust actually inherits from Haskell, by the way, Haskell and C. So if we decide that we're going to use one of these languages that do not have garbage collection and memory management, then we might want to strongly consider Rust over C, because it's been determined that we can reduce memory security risks, which is one of the largest risks of languages today, by, I remember 70%. I may be off by 5% or something, but it's a significant amount. And so I learned all of this in the last year, just following this CTO for Azure, Mark Rusanovic. And it just shocked me when I heard him, of all people, you know, he built his entire career and life on C, literally. When I heard him saying, hey, we need to look at C as a deprecated language and all new projects will start in Rust, that's when I started down this path of learning Rust. And that was about a year ago. And so we spent the first part of the meeting like setting the stage and talking about the why and the use cases. And then right when you walked in, we said, okay, now let's go into Rust and look at some of the basics now that we've set the stage for, you know, why. Yeah, go ahead.
So how much of programming is done on Rust in big companies.
Yeah.
Like big tech or, for example, IBM.
Yeah, I have no idea. I'm really sorry. I would be the wrong person to ask. And I'm not sure that data point would be really valuable in making a decision at this point, because I don't think I would want to look at how many people are using it today. I think a more interesting question would be how many people have plans to use it in the next 6 or 12 months, or how many people have plans to use it for any new projects. Like that. That's the way I might phrase that question. I still don't know the answer, but I think that would be a little bit more meaningful, because I'm sure there are a ton of people like me who, we just started with our API in Rust. So depending on how you ask the question, I might answer it in a different way. So.
And if Rust is taking care of garbage collection, then there may be trade-offs. Maybe Rust is slow in executing.
No, and the reason why, and it's a very great question, so we want to be careful. So the way that you phrased that is you said Rust is taking care of garbage collection.
Yeah.
But to be technically accurate, what we would say is that Rust at compile time is doing a bunch of checks to make sure that you don't need to be as sophisticated with your memory management. And I want to be really careful about that, because I would not consider myself a master expert at Rust, right? I think you can get very sophisticated and you will take ownership for memory management in Rust. And I want to be clear about that. You do have a responsibility, but because there are checks at compile time, they can eliminate up to 70% of those errors.
Okay, so we can take care of memory garbage collection or memory leaks in C and C++ also.
I have yet to see anybody prove that to me. Then why are people taking data off of our clouds almost every day?
But even their business is going on very good, like Microsoft Azure or
Sure.
AWS.
That reminds me of the meme where there's like somebody sitting around, there's fire all around, but they're just like calmly drinking their coffee. I mean, we can pretend, if you want. But, and you know what? You're right. A lot of my colleagues would disagree with me. They would say exactly what you're saying right now. They'd be like, Paul, what are you talking about? Like, you're being silly, like always. Like, what's the drama? And I'm just here to tell you that that we do have problems with the C language. We do have problems with memory leaks. I think when we look at things like SolarWinds, that's a classic, example of where things can go horrifically wrong. And so I don't think we have this under control. And some of this is also just I do have to admit, some of this I'm going on the blind faith of Mark Rusanovic, who, again, Chief Technology Officer of Azure. He's got a lot more experience than I do in developing with these languages. He's built his entire career developing for C. Just do the Google search. You'll see, just Google Mark Rusanovic and Rust. He's been talking about this very vocally, very loudly for over a year now. And he has stepped up the language. He is now saying that not only should you consider Rust in these use cases, but he's taking it a step further and saying we should now start considering C to be an obsolete language. That's just Google it. That's coming from him.
Yeah, he has built a company also on these tools which he built on C and C++.
He built, he has sys internals. He's been programming sys internals a long time. Like, I mean, I feel like I've been hearing about it for a couple decades, when he first started sys internals. Yeah, exactly. So, who am I to, don't get me wrong. I'm not afraid to question most people about most things. But, when it comes to languages like these and the problems with memory and security, I'll default to him for now. And by the way, I think the rest of the industry Google uses Go.
Yeah.
Right? Like, it's not only Microsoft, right? So, okay, great. I hope that helps. So then let's just look a little bit more. So let's go into the next step would be to look at something like, so from hello world, you typically go next to something like a, number generator or a guessing game, right? And so that's what you can see here. And so what's interesting now is you can start to see some of the libraries, coming into play. And there's actually a file that's associated with each application. So it's called cargo TOML. It's actually an interesting story about the extension.
Markup language.
Yeah, and it's a guy named Tom, or I forget what it is, but it's actually a cute story if you want to Google what TOML is. But this is basically where, you can see we're registering some packages in a dependency. And it makes sense that, what we're doing here, because it's a number guessing game. So we're going to need to generate a random number. So we're taking the next baby step in hello world and making use of a library that will allow us to get a random number for our guessing game.
So these extra libraries are dependent on C.
Even Rust, as far as I know, it still has it doesn't have a dependency on C. It has a dependency on a C library. This is the
package.
So for the people watching, you couldn't see me. I just went over and I pointed to the 35 billion with the B downloads of only 118,000 crates. So when I pulled this up in front of a bunch of JavaScript folks, they were stunned. They even when you compare the number of downloads to the Node package manager, this is pretty impressive. The key takeaway here again is we're moving up. We go from hello world to the number guessing game, and so the next concept that we introduce is how we can use libraries and set dependencies, and we'll do that with crates. So another one I'd like to show you is connecting to Power Platform. So one of the, of course, being here at the Microsoft offices and just having a lot of colleagues at Microsoft and in the community and working with the technology, a lot of folks are building stuff on top of Dataverse and Microsoft's Power Platform. And that's a good thing. Dataverse, actually, a lot of people miss this. But if you're in the enterprise space, in my opinion, one of the most useful things about Dataverse, I think especially from a data engineering perspective and an AI perspective, is that Dataverse is built on top of the common data model from Microsoft. And so the common data model is a set of schemas that have been defined across various industries. So imagine having data schemas for ERP systems in the automotive industry or in the healthcare industry, and let's just stick with healthcare because we're at a healthcare user meeting. And also it's what I'm most passionate about. You can imagine that we start talking about FHIR and sending data back and forth. If we can all agree on a common schema beyond FHIR, right? So we already agree on one in healthcare. We say, okay, we're going to use FHIR, or, we should acknowledge there are other ones too, but FHIR is the biggest standard in the space, that's certainly in our world in the US. So, we can standardize around FHIR, but then we may want to standardize on other data entities, et cetera, right, to run the business. And so that's what the common data model gives us. And so then what they do is on top of the common data model, they add something called Dataverse. And so Dataverse lights up the common data model by adding, security and a bunch of enterprise features, and makes it usable. It makes it so people can create. They used to call them entities, but the team has been making it just easier and easier and easier to use. Now they call them tables, and You know, so but underneath it really is still ERP. They're trying to hide a lot of it, but it's the ERP stack from Microsoft, and it's built on top of the common data model. So because of that, Microsoft Cloud for Healthcare is built on top of that. And so I would submit that, you know, that makes a chunk of code like this pretty important, because it gives us what we need to run off and connect to Azure, and then connect to our Dataverse environment, and then consume data from our Dataverse environment. Okay, with that, I'll pause for questions.
So Rust is used only to build desktop software, not websites.
Well, yes, I would say that the best use case for Rust is to build the things we talked about, secure, performant. But there are crates that do allow you to, as a matter of fact, that's a great segue into what I was going to show next, which is how you use Rust to build an API. And so there are crates that you can download that would allow you to create and serve up web pages. And I think we'll start to see a lot more of that as the language grows and people do more and more with it. And remember that one of the things that makes a language powerful is as the community grows around it, right? You get more and more of these useful crates, etc.
And I'm an embedded C programmer, and Rust is definitely expanding in the embedded world on really low level stuff.
That's great, yeah. And please, any other feedback you have, because I know you have a ton of experience in the C space, and you're just starting to get into the Rust now. It sounds like, right?
I can talk a little bit. I mean, first about talking about the garbage collection. That there's a ton of overhead for garbage collection. So if you're running an operating system, having garbage collection isn't that big of a deal. But if you're trying to really do, you keep saying running stuff in your watch, but you're pointing at a watch that can probably run.
Yeah, I know. I thought about that too. Yeah. It's a pretty powerful watch.
How many tens of thousands of times more powerful than what we used to go to the moon or whatever.
Yeah.
You're talking about like a really dumb watch that has a really tiny microcontroller in it, but you want it to, tell you happy birthday or whatever, then that's more of Rust or C. But when I'm developing C, if I run a program and I screwed something up, it might crash out and say segmentation fault. And what that means is that, it tried to access a part of memory it wasn't supposed to access. And I guess it's the OS at that point shut it down. But with Rust, that wouldn't happen, because with Rust, when I would go to compile the program, Rust would say, oh no, there's a possibility here that function will try to access a piece of memory that it doesn't necessarily have access to. And so if you actually look, especially at the really low-level embedded stuff, the compiled C code and the compiled Rust can sometimes, or is often identical for some of the simple stuff. But for the C, there isn't this guarantee from the compiler saying, oh, this is going to be memory safe.
Yeah.
It's just trusting that the programmer knew what they were doing to keep it memory safe. Whereas for the Rust compiler is saying, not only am I saying that this will run, but it'll run safely.
Sure.
I wouldn't let you compile.
So how does the Rust compiler detect safety?
Math.
There's a lot of rules about, like for C or anything, if you're working with multiple threads, there's all these different locks and things to make sure that different threads aren't trying to access the same, parts of memory and things like that. But for Rust, it's even just single threaded, just everything. Like everything needs permission to access.
I remember reading about a missile that was in development that had a memory leak. So the missile the software would crash after 12 seconds. So they just gave it enough RAM so that by the time it ran into that critical error, it would have already exploded.
Yeah.
Well, Donkey Kong Country 64 for the N64 required the N64 memory expansion, but it's not because they actually used the extra doubled RAM. It's because it also had a memory leak, and it would crash really quickly if they didn't have the doubled RAM.
Interesting.
And speedrunners actually run into this. If you run the game for like 12 hours straight, it'll still crash from running out of memory.
Interesting.
And there may be some great use cases for gaming with Rust too. By the way, I'm the exact opposite of gamer. Like I know very little about gaming and writing video games. And there's a video game. So
even I think the same way. So it's a very big thing that Microsoft CTO says that
Yeah.
Rust is the future. But I think these are his thoughts, and every CTO has some or the other thoughts.
Yeah.
And I think in this previous 40 years, every day there was new language which came up
Yeah.
and which went away also
Yeah.
without anybody knowing.
I agree, but what I would submit is that I think there's a little bit more urgency now because of what we're seeing, because of the state of the world. People, I don't know how else to say it, but people just don't like us as much as they used to, so they're hacking our networks. Like, that's just a fact. It's been happening for 5 years. You'd have to be living in a cave not to acknowledge that, right? And so, there's that, right? So,
well, I think you have to
Go ahead.
acknowledge that people make mistakes, programmers make mistakes.
Thank you.
Everyone makes
Yeah.
mistakes. And if you're letting people program in C,
Yeah.
they're going to create code with bugs in it, and
Yeah.
those bugs might expose these errors. And you can't expect people to program bug-free code.
Yeah.
But if you have the compiler doing these checks that are going to get rid of 70% of those vulnerabilities, then the code is going to be that much safer.
Yep. And I would submit. Yes. Sorry, I lost my train of thought. I agree with you 100%, and I really appreciate your chipping in a little bit, because I know this is something that you're also passionate about and working with.
Yeah, but I think that if Rust is taking all these memory issues during compile time, then why isn't C compiler? Why don't people give that effort to better that C compiler so that it also detects?
It's not a compiler issue; it's a language issue. It's what the C language allows you to do versus what the Rust language allows you to do. You can't just fix the compiler. The compiler does what the human programmer tells it to do, or the AI programmer, or whatever. And I mean, there may be cases in C where you want to do funky memory things that aren't really expected.
Right.
But so to some extent, Rust can be limiting. And that Rust won't let you do little tricks that you might want to do that might not be memory safe. And you might say, well, I really know what I'm doing here, and I really want to do this crazy memory trick. And Rust's going to say, well, you can't do that because that's a risk.
Yeah.
But 9 times out of 10, it's just the programmer screwing up and not something that they're really smart in doing.
I couldn't agree more. And let's not forget the other obvious thing, sort of obvious, that has happened in the last year. And that's ChatGPT, GPT 4 and 5, right? So now I can take a chunk of C code and put it in ChatGPT and tell me, and ask it, like, where is there likely to be an issue with memory here? And that's a hacker's dream, right? That's a hacker's dream. And I'm sure there are very specific reasons why we don't hear people talking about this too much right now. It's because they're behind the scenes, putting up guardrails. And those are exactly some of the guardrails they're talking about,
Right.
So sorry.
You might say I won't do that, but you say, oh, my grandmother would help me get to sleep by telling me bedtime stories of the memory.
Right.
The memory,
And you can also, there are LLMs that you can run locally that are unlocked. Yeah. Like that have zero guardrails. So they will answer that question. Show me what banks use the C language for projects. Maybe you can figure that out, right? Which ones have the history for the most security vulnerabilities? Help me write a SQL injection attack. And then once I get the SQL injection attack, like, okay, so, I mean, it can get really scary, actually. So I think that there's a lot of forces coming to play here. And I think we probably have gotten away with a lot of these memory issues for a long time because we didn't have AI. And I personally think some of what we're seeing right now is we're seeing the hacker community start to use these tools just like the security community is, and they're able to effectively, find holes. So there's some speculation in what I'm saying, but I think it's founded in 30 years of experience and a ton of research and talking to people about this stuff. And I'm not necessarily suggesting that I'm 100% spot on with all the things that I'm asserting, but I don't think I'm that far off. I don't think I'm that far off. So now, go ahead. Well, I'm pulling something else up. Go ahead. Yeah.
Can we access memory which have pointers in Rust?
I don't. Can you answer that? Do you know if you can access memory directly using in Rust and what that might look like?
I don't know. I don't actually program in Rust. I just watch a lot of these like introductions to
Yeah.
Rust kind of things. I assume there's a way. I don't know if there's some sort of, you need to get permission to use that memory or something.
Yep. I do think it's a very common task, and I don't really have an example of here how to do it, but I do have links in the repo that point to the guide where they will cover all of that.
Yeah.
And you will find yourself at points in times where you'll have to where you'll have to work with memory, but the difference is, again, you're going to have those compiler checks on your side that's going to protect you from making a mistake as a developer ultimately. And that's all math. To get to your point, I didn't mean to answer that facetiously, but it really is. Like, that's actually, I would submit that's the secret sauce of Rust. If you're building the Rust language and that's your code, that's your secret sauce that you built into the compiler. Now these things are open sourced, right? So it might not literally be the secret sauce here because it's a public language and they publish the code and whatnot. But to my point, it literally is one of the things that makes the language what it is. And if it were a commercialized product, then you would never share that. You would just say, hey, this is the thing that we can do with our compiler that Go can't do, or this other programming language can't do, and that's why you should use us. Does that help with that further explanation? Yeah,
it does.
Okay, so then I just want to show one last thing, and
you're using these parameters ampersand str. Are you passing address? Parameter.
Where do you see this?
In this function.
Yeah. At the top, I am, yeah. And actually, this is the code I thought it was. This is not to build an API. This is actually using a client to call off to ChatGPT. And I think for some reason, I haven't run this in a while. I think I might be using the wrong key or something. I can't imagine it's my quota, because I hope it's not my quota. Oh, I should double check with my developers, make sure somebody's not making a mistake. But anyway, not quite sure what's happening here. But the code's running, like it's going off and it's connecting and it's pulling back. Now, one of the things that I just want to caution you about is that if I'm gonna build an API and I'm just gonna be making a bunch of REST calls, Rust might be overkill for that, right? Because you'll get the safety. If you're doing a bunch of other stuff outside the calls, you're gonna get the concurrency and you're gonna get the safety. But the performance part, I would just wonder a little bit. If like most of your code is doing REST calls, then it may be overkill to use Rust. That said, if you have chunks of your API it's algorithms, it's actually doing something, but you have to make a call to a web service, that's a different thing. So, and so I'm just mentioning this because it's something that we've had to deal with recently, so we've started to separate. So now we have like the things that we want in our Rust API and the things that we want in our standard API. And the boundaries that we've drawn is if we want, like our intellectual property goes in the Rust API. It's protected there. I feel most secure about it being there. And then everything else I default to our standard API.
What's the standard API coded in?
.NET Core. It's a garbage collection language. Just leave it at that. So there is a crate. There's a couple of them. There's one called Actix is the one I believe I've been using. And what this will allow you to do is it spins up a little HTTP server. And that's how you get your API. So what you do, it will be faster for me to explain this than to find the code. So what you do is you use this library and then you create it's really a socket. You're creating like an HTTP TCP IP socket, HTTP, and then TCP and IP underneath it. And then what you can start to do is, so that's one part of your code. And then you start to build out the API, building functions. And then when people want to call your API, they call the port that you've defined in Rust. It's a really cool model, actually. That's when I saw the way that they implemented the web API. And in all fairness, I haven't tried to do it in C. Maybe I would have been just as, pleased with how they did it. But I really like the model and how I could. There's just something about the way it makes it easy. It's very easy to sort of view what's going on with the API, in my opinion. And in all fairness, our Rust API is, slowly growing. I may have a different opinion in a year, as we get more and more lines of code up there. So that's it. I think if we're going to recap this meeting, I would just point out that, again, the key thing is that, you don't, of course, pick up a hobby, learn Rust if you want to. Great. Let's just, because that's a great thing to do. But if you don't have time for hobbies and you're really looking at this from a business perspective, then what I would submit is that it's really important that you pick the right use case, that you really want to make sure that you're picking use cases where you need the performance, where you need the extra security, the memory protection, and concurrency. And you're right, I keep pointing at my sophisticated smartwatch that can probably run a ton of stuff, and most people don't pick up on that. But you make an excellent point. It's not even this watch, because this watch can run a bunch of stuff, but it's that pacemaker, right, that we were just talking about, or that implant that goes into the knee device, that type of thing, or the blood monitor devices that your company works on, where you need to do some stuff and then do some other stuff. Those are the use cases.
Yeah, I work with microcontrollers, not microprocessors.
There you go.
Which
Yes.
is kind of an arbitrary distinction, but
Yeah.
generally on the less powerful side, where
Sure.
you're not running an operating system.
Super cool. Like I said, I have a newfound interest in that after learning about some of the things these smart implants are doing in these medical devices.
Yeah, but who will hack these kind of devices like pacemaker?
Yeah.
These are not even connected to internet.
Well, that's not true anymore. Like the company I was talking about, Canary, they have a knee implant that has a 20-year battery life, and it outputs data every night to your cell phone, and then it pipes it to your doctor's office. And they already have it in thousands of patients.
And it's not necessarily about hacking. It's about, well, if after 5 years, because there's a memory leak, the pacemaker crashes and the heart stops, then you really wanted to make sure you used a memory safe language when you were programming.
That's a really great example. I'll use that for the next presentation. I like the knee one too. Like so the next generation of the knee one that I'm talking about, they'll have the ability to detect vibrations and detect if it's going to wear out. But you're right. That's a great example, because we forget this sometimes. But I should say that folks outside of healthcare, maybe they don't see as much of this. But what I'm trying to say is a lot of what we do is mission critical, right? Mm-hmm. A lot of what we do in healthcare is mission critical. Like it can literally mean the difference between somebody surviving a surgery, or certainly, even if we were to be optimistic, saying, let's say, they're having a much better outcome, right? The probability of a positive outcome from treatment. And so thank you for bringing that little bit of reality.
Talking about things like that, where things crash after a very long time. I know AMD recently released an errata for one of their old EPYC server processors, that they realized that if you don't reset it for a little over 3 years, some hardware timer inside overflows and the whole thing crashes.
Interesting.
And so they're saying, if you run these, you have to reset them every 3 years.
Wow, that's interesting. When you were telling that story, I'm going to date myself now, but it reminds me of when I first got started in this industry, Novell Netware. They were the big servers. Microsoft didn't even have Windows NT yet at the time. And but then, so I was jumped on the Microsoft bandwagon really early on, in the early 90s with Windows NT. And I remember we were going to all these businesses, and it was always the same thing. There'd be a closet at the back of the office somewhere with a Novell server, but they were famous for that screen. And it would always tell you, this is how many days that this server has been running for. Do you remember, anybody remember that screen? So you would see some of these Novell servers that would literally just be running for years and years and years without ever being rebooted. And as a matter of fact, Windows got a bunch of flack for that when they first came out with their first server product, because everybody's like, what's this? You're going to reboot all the time? You got to reboot your Windows server? And but in hindsight, they clearly did end up putting together a better product. NetWare didn't last very long once Microsoft got serious. So with that said, let me just say goodbye to the folks online. Thank you for being here. Thank you for catching the stream. Again, look up Boston Healthcare Cloud Community and our new community on Twitter. And hopefully you found our presentation useful. Okay, cool. So I'll stop this.